Dear students, welcome to the second session of this solution chapter. In the previous, we have discussed what a solution is and how the solutions has been classified based on the which one? The physical state of both the solute and then the solvent. Broadly, first they are classified as solid solutions, liquid solutions, and then the gaseous solutions. Again, each has been further classified into three different types: SS, LS and GS. All these are solid solutions. Then SL, LL and then GL, that is called as liquid solutions. And finally we are having the which one? SG, LG and then the last one is GG solutions, that is the gaseous solutions. Again, the solid solutions or solid solutions can be of two types called as a substitutional solid solutions and then the interstitial solid solutions. After knowing the definition and then the examples related to all the 9 different types of solutions, we have discussed or we have mentioned some of the symbols relative to the solution chapter, because as far this is concerned, you have to be very familiar with respect to the symbols that has been allotted. For example, W refers to mass, M refers to molecular mass, E refers to equivalent mass, F refers to formula mass, X refers to mole fraction, N refers to number of moles, V refers to the volume, capital P refers to the vapor pressure, small p refers to the partial pressure, and then the TB or TF refers to the boiling point of the solution or the freezing point of the solution, whereas TB naught or TF naught refers to the boiling point or freezing point of the solvent. Okay. In addition to that, we are having some of the subscripts in the form of which one? The 1 or sometimes it may be the naught we are mentioning. It is called as a solvent. It is a solvent. Suppose if it is 2 or sometimes it may be the small s as a subscript, then it is called as a solute. Suppose if we didn't have any subscript relative to the given mathematical term in the form of the respective symbols, we are calling that as a solution. Okay. So after this, now what is concentration of a solution? Concentration, or sometimes it can also be referred as the strength of a solution. Strength of a which one? Solution. Concentration, which is also called as the strength of a solution. So here this is defined as amount of a which one? Substance, and that substance is preferably the solute. Amount of a which one? Substance, and that substance is preferably the solute present in the given amount of a solvent, or in some cases it may be the solution also. There may be a variation with respect to that. Either it is in the amount of that particular substance or a solute that has been present or dissolved in the given amount of the given which one? Either the solvent, pure solvent, or sometimes it may be the solution. Usually the concentration is expressed in terms of mole per dm cube or mole per liter. It is with respect to molarity actually, but either it can be expressed in mole per dm cube or mole per liter, or if I prefer the SI unit for that, it becomes mole per which one? Meter cube. That's only the general concept. Okay. But here this concentration or the concentration goes on increasing if the solute concentration is more or solvent or the concentration or solution is found to be the less, and those type of solutions are called as concentrated solutions. The solution of very higher concentration is called as what? Concentrated solution. Then what is a concentrated solution means, or what it contains? It usually contains the higher amount of the solute but dissolved in a lesser amount of either the solvent or it has been present in the given solution. Or to decrease the concentration of solution, the solute must be less, or the solvent or it may be the solution must be more. And those type of solutions are called as the diluted solution or dilute solution. Means the solution of lower concentrations are called as which one? The dilute solution. Means a dilute solution means the amount of the solute is found to be very, very less as compared to the very large amount with respect to the solvent, or sometimes it may be the which one? Solution. And that solution is preferably considered to be the what solution? The dilute solution. Okay. So this is about the main term with related to the solution chapter, that is called as a strength, or it is also called as concentration of a which one? Solution. Okay. This concentration or strength of the solution is expressed in 9 different terms. We are having the 9 different terms related to the strength, or it is also called as concentration of a which one? Solution. Okay. Let us have the first. The first one we are considering is various terms to express the concentration. Sometimes it can also be referred as strength of a solution. Strength of a which one? Solution. Various terms that has been used to express the concentration of a solution, which is also called as the strength of the solution. As far the syllabus for the second view is concerned, we are having totally the 9 concentration terms. The first one is molarity. This is having a symbol of capital M. What's that? Molarity. What's the number of molarity here? It is the number of moles of a solute. Number of moles of which one? Solute. That has been present, or sometimes we are using the word as dissolved also. As if it is present means it is already gets dissolved in 1 dm cube of a which one? Solution. Present in how much? 1 dm cube of its a solution. It is not the solvent here, it is present in the 1 dm cube of the respective solution, means it is called as which one? Molarity. So mathematically, molarity M is given by, so here capital M is not called as molar mass, it is just only the which one? Molarity. Okay. N2 divided by V dm cube is a formula. What is N2 here? N refers to the number of moles and the subscript 2 refers to which one? Number of moles of a solute that has been present in what? Volume. No subscript means it is called as a volume of the solution. But that volume of the solution is to be expressed in which one? Decimeter cube, or sometimes it may be the liter also. Means the number of moles of a substance or a solute that has been present in or dissolved in exactly 1 dm cube of its saturated solution, or the given solution, is called as which one? The molarity. Or this can also be mentioned in the form of W2 divided by M2 into V expressed in dm cube, because the number of moles is given by the formula what by what? W by M. What is the number of moles? Mass of that substance divided by the respective which mass? The molar mass. Here, what is W2 here? Mass of the solute. Mass of the which one? Solute, because the subscript is here 2. What is M2 here? Molar mass, or it is also called as a molecular mass of that particular solute. And as usual, V dm cube means it is a volume of the solution expressed in which one? The dm cube. Or if it is expressed in terms of another one that is called as cm cube, then we are having the formula of the type. So instead of decimeter cube, suppose if it is expressed in cm cube or ml, then the final formula becomes 1000 W2 divided by M2 into V expressed in which one? Solution. Sorry, which one? The cm cube, or sometimes it may be the ml. Means these are the 3 different which one? The mathematical forms related to the which one? The molarity of the solution. What first molarity is? It is the number of moles of a which one? Solute that has been present in how much? Exactly 1 dm cube of which solution? The given solution. So mathematically, molarity capital M is equal to what? It is N2 divided by V. N2 by V. N2 is number of moles of a solute divided by volume of the solution expressed in dm cube. Or number of moles is given by mass divided by which mass? Molecular mass. Therefore, instead of N2, we have to write that as what? W2 divided by M2 into as usual volume expressed in which one? dm cube. Suppose if the volume of that solution is expressed in cm cube or milliliter, then it becomes what? 1000 W2 divided by M2 into what? V expressed in centimeter cube, or sometimes it may be the milliliter. Okay. So let us have the second one. Molality. So what that particular molality refers to here? So instead of this same, just we have to express that in the form of a solvent. Instead of what? The solution that has to be expressed for the dm cube, just we have to express that in the form of another one that is called as the kg of a solvent. The same definition. It is also the number of moles of a solute. Number of moles of which one? Solute. Present in, the difference is, present in what? 1 kilogram or kg of a pure solvent. Means exactly we have to take how much? 1 kg of a solvent, pure solvent. To that we have to add the number of moles of a which one? Solute. Then what the strength that we are observing, or the concentration that we are observing, is called as which one? The molality. So means it is a same number of moles of a substance or a solute, or it is also called as amount of a substance or a solute present in how much? 1 kg of a pure solvent, or that is, instead of present we can use the word as the dissolved. Okay. So mathematically, molality is given by, it is having a symbol of small m. Capital M is molarity, small m is what? Molality. So here N2 divided by W1 in kg. What's N2 here again? The same. What is that? Number of moles of 2 is what? Solute. Divided by what is W1? Mass of 1 is a solvent. That solvent has to be expressed in terms of which one? The kilogram. Therefore, N2 divided by W1 expressed in kg refers to the molality of that solution. Then, instead of number of moles, if I know the mass of that, then we can have the extended formula that is called as W2 divided by M2 into W1 expressed in which one? Kg. Because how to get a number of moles? Mass divided by which one? Molar mass. Means mass of the solute divided by molecular mass of the solute into mass of the solvent expressed in which one? Kg or kilogram. Suppose if the same thing, mass of the solvent is expressed in grams now, then it just becomes 1000 W2 divided by M2 into W1 expressed in which one? Grams. So here molarity is equal to what? N2 divided by V expressed in dm cube, or W2 divided by M2 into V expressed in dm cube, or 1000 W2 divided by M2 into V expressed in cm cube or ml. Whereas molality small m is equal to either N2 divided by W1 expressed in kg, or W2 divided by M2 into W1 expressed in kg, or 1000 W2 divided by M2 into W1, but that W1 is expressed in which one? Grams. So here molarity is, or first we will have the dependence. Relation between the molarity and molarity. Molarity and the molarity. So what is the relation between this one? Because here it is expressed in terms of solution, here it is expressed in terms of which one? The solvent. Then how do these can be related as? So there is a difference with respect to the density. If that be the case, we can have the relation between that. That is 1 by m is equal to d by capital M minus M2 divided by 1000. This is the relation between which and which? The molarity as well as the molality. What is small m here? Molality. What is capital M here? Molarity. What is D? Density of the solution. Density of the what? Solution. Then what is M2 here? It is molecular mass or molar mass of the two, means it is a solute. Or if I make a simplification relative to that, 1 by m is equal to, I can take the LCM as what? 1000 m. 1000 times the m. Here it is m means here it is 1000 means 1000 is left here, therefore it is 1000 in terms of d. 1000 in terms of d. Minus 1000 is there, 1000 is there here, but we left with only m. M into what? M. R. On simplification, m is equal to 1000 capital M divided by 1000 d minus m2. What this is? What this is? The relation between the molarity and then the molality. Means molality is equal to 1000 times the molarity divided by 1000 times the density minus molarity into molecular mass of the respective solute. So that we can have the relation between which and which? The molarity and then the molality. So here the difference is 1 dm cube of the solution, but here it is 1 kg of the solvent. So here molarity is dependent on temperature, whereas molality is independent upon temperature. That is, as if we know that volume changes with which one? The temperature. As the temperature changes or as the temperature increases, volume increases. As the volume increases, the molarity goes on decreasing. Means molarity is temperature dependent. But here, the molality is not involving any volume terms. It involves only the mass terms, but not the which one? The volume terms. That is why molality is found to be the independent upon the temperature. So that makes a difference between which and which? The molarity as well as the which one? The molality. Okay. So next we will have the third concentration term, that is called as normality and then the formality. The first two we have discussed that in the form of which and which? The molarity and then the normality. Now we will switch on to the which one? The normality and then the formality. Let's have the third one. It is normality, that is n. It is the number of gram equivalents of the substance, and that substance is preferably called as a solute. Instead of number of moles, what you have mentioned? Number of which one? Gram equivalents of the substance or the solute present or dissolved in. Again, same. How much? 1 dm cube of the respective, which one? The solution. Respective solution. Number of moles instead of that. Just it is the number of what equivalents? The gram equivalents of the substance that has been present per 1 dm cube of the solution refers to which one? The normality. So mathematically, normality n is equal to number of gram equivalents number of which one? The gram equivalents divided by volume expressed in dm cube. What is Neg here? It is number of gram equivalents, Nge or Neg here. Number of gram equivalents. Number of which one? The gram equivalents. So here, number of gram equivalents is given by the formula W2 divided by E2 into V expressed in dm cube. Because NGE, what is that NGE here? It is the number of gram equivalents is given by the formula mass divided by respective which mass? Equivalent mass. W by E. W by E. Number of moles is calculated by the formula mass divided by molar mass. But number of gram equivalents is given by the formula mass divided by which one? Equivalent mass. Which can also be given by, number of gram equivalents is also given by normality into volume divided by 1000. It's the final case. Only when we are solving that one, we will get that in the form of normality into volume divided by 1000. Okay. This can also be equal to 1000 times the W2 divided by E2 into V expressed in CM cube. Instead of dm cube, we have to express that in the form of what? Cm cube, means we have to get the 1000. Therefore, normality is equal to, we are having the three formulas, we got that. One is number of gram equivalents, NGE divided by volume expressed in which one? Dm cube, or W2 divided by E2 into V expressed in dm cube. W2 is the mass of the solute. E2 is the equivalent mass of the solute, and then V is volume of the solution expressed in dm cube. Suppose if the volume of the solution is expressed in Cm cube, then it is given by normality is equal to 1000 W2 divided by E2 into V expressed in what? Cm cube, or it may be sometimes ml. So this concept is called as which one? The normality. Okay. So here another thing is very clear. Equivalent mass E is calculated by the formula of an element. Suppose if it is an element. If it is an element, it is the equal to gram atomic mass divided by, or simply we will mention that in the form of atomic mass by valency. Atomic mass by valency. Suppose if it is a compound, equivalent mass of a compound, suppose if it is given by molar mass, or sometimes it is also called as molecular mass. Generally, preferably we will mention that in the form of what? Molecular mass divided by respective which mass? Equivalent mass is equal to that in this. Either basicity or acidity or total positive charges on all cations, or the change in oxidation state, or number of electrons lost or gained. Number of electrons lost, or sometimes it may be the gain, or indirectly it is a change in oxidation state also. If it is a what? Compound. Molar mass or molecular mass divided by basicity means it is for acid. What is basicity here? Number of replaceable H plus ions present in one molecule of an acid is called as what city? Basicity. Similarly, what is acidity refers to? It is for a base. Then what is the acidity here? It is the number of replaceable OH minus that has been present in one molecule of a base. Suppose if it is a salt, means it is a total positive charges on all the which one? Cations. Suppose if it is a reducing agent, it is the number of electrons that has been lost. Suppose if it is a oxidizing agent, means it is the number of electrons that has been gained. Or indirectly it is simply the change in the what state? Oxidation state. So that we have already discussed that in the previous first year PUC chapter, that is called as redox reactions, when we are discussing the concept of which mass? Equivalent mass. Suppose if it is an element, it is just what by what? Atomic mass by which one? The valency. Suppose if it is a compound, means it is the molecular mass divided by either basicity or acidity or total positive charges or all the cations, or number of electrons that has been gained or number of electrons that has been lost. Okay. So this is the concept of which one? Normality. Then the fourth one is formality. What that formality is now? It is also the number of gram formula mass of a substance. Number of which one? formula mass of a substance, or it is also called as a solute, that has been present in, say, how much? 1 dm cube of the solution. 1 dm cube of the solution. Number of what? Gram formula mass of a substance or a solute that has been present in exactly 1 dm cube of the respective solution means it is called as formality. So mathematically, formality is equal to, it is having a symbol of F, is equal to number of gram formula mass NGFM divided by V expressed in which one? dm cube. NGFM means number of gram formula mass of a substance. Number of which mass? Gram formula mass, which is also equal to W2 divided by F2 into V expressed in dm cube, which is also equal to 1000 W2 divided by F2 into V expressed in cm cube. So these are the 3 different formulas where we can expect the, which one? Formality. Here F2 is called which mass? Formula mass. What's that mass? Formula mass. What is formula mass here? It is a mass of that particular substance or the formula that has been in 1 unit divided by respective charge on the ion. Either it may be cation or it may be the anion. Okay. So that is about the which one? The formality. Usually the formality is a very rare case that we are appreciating. Okay. So that usually we are concentrating either on the molarity or a normality, or it may be the molality. But this is the very special case, or it may be the rare case with respect to the strength or concentration of a which one? Solution. Okay. So now we will have the relation between normality and or before moving to that, let us have the concentration terms with respect to various let's continue the same thing here first. Various terms to express the concentration of solution. Okay. So here first we will have the relation between normality and molarity. N is normality, M is molarity. In general concept we are taking, normality is equal to, or I can just mention the symbol itself, okay. N is equal to M into molar mass divided by respective which mass? Equivalent mass. This is a general relation between a which and a which? The normality and then the molarity. Normality is always equal to molarity into molecular mass divided by which one? The equivalent mass. Strictly for acids, if it is for acids, normality is equal to molarity into basicity of an acid. So previously I mentioned what is that basicity. Here it is the number of moles of which one? Sorry, number of replaceable H plus ions present in one molecule of an acid. Suppose if it is a base, for bases, normality is equal to molarity into which one? Acidity of a base. Acidity of a which one? Base. What is acidity? Number of replaceable OH minus that has been present in one molecule of a base. Or there is another alternate definition for that. Number of replaceable H plus ions accepted by one molecule of a base is also called as acidity. Suppose for salts, N is equal to M into total positive charges on all the cations. Normality is equal to what? Molarity into the total positive charges carried by all the cations refers to with respect to salts. With respect to oxidizing agents, normality is equal to molarity into number of electrons that has been, as it is an oxidizing agent means, oxidation means it is loss of electrons. So loss of electrons means it has to get reduced. Reduce can take place number of electrons that has been gained. Or indirectly the change in oxidation state, that's also possible here. Suppose for the last one, that is called as a reducing agents. For what agents? Reducing agents. Normality is equal to molarity into number of electrons that has been lost. Number of electrons lost means electrons loss is called as oxidation. Any substance undergoing oxidation means it is an example for a reducing agent. So this makes the relation between a which and a which? The normality and molarity. Or in general, instead of knowing all of this, it is just better to have normality is equal to molarity into respective molecular mass divided by what mass? Equivalent mass. So the ratio of molecular mass divided by equivalent mass will give basicity of an acid for acids, acidity of a base for bases, total positive charges on all cations for salts, number of electrons that has been gained for an oxidizing agent, and number of electrons lost is given for a reducing agent. Okay, so that is the relation between a which and a which, the normality and then the molarity. Okay, so next is for same solutions, of different concentrations, molarity into volume of the first solution is equal to molarity into volume of the second solution, or normality into volume of the first solution is equal to normality into volume of the second solution. Okay. Also, M1 V1 plus M2 V2 is equal to M3 into V3, which is also equal to M3 into V1 plus V2. Suppose if we are having the two solutions are different concentrations, then molarity into volume of the first solution plus molarity into volume of the second solution is equal to molarity into volume of the mixed solution, that is M3 into V3. But how V3 is obtained? It's a combination of which and which? V1 plus V2. Suppose for different solutions, for which one? The different solutions. In terms of normality is very same, N1 V1 is equal to N2 into V2. That's the same case. But in case of molarity is different. That is, A1 into M1 into V1 is equal to A2 into M2 into V2. Here, A1 is equal to MM1 divided by EM1. A2 is equal to MM2 divided by EM2. This is a special case. For which one? Different solutions of a substances. Either it may be same concentration or a different concentration, I don't know. But in the first case, what you have mentioned? For the same solutions of which concentration? Different concentration. But here, for the different types of solutions, suppose if it is an acid base or an oxidizing agent and a reducing agent, if that be the case, then in case of the normality it is always equal, N1 into V1 is always equal to what? N2 into V2. But in case of the molarity concept, A1 into M1 V1 is equal to A2 into M2 into V2. What is that A1 here? It is a molecular mass of the first substance divided by respective equivalent mass of the substance. What is molecular mass of the substance divided by equivalent mass? Either it is called basicity of an acid for acids, acidity of a base for bases, total positive charges for all cations for salts, number of electrons gained for oxidizing agent, number of electrons lost for reducing agents. So there also it is same. A2 is equal to molecular mass of that substance 2 divided by the respective equivalent mass of the second substance, that is called as 2. Okay, so this is the different concept if I choose The same solution is the case that these two formulas are applicable, whereas for the different solutions we are having the second set of formulas. Okay, so this is about the third and then the fourth terms in the form of which and which, the normality and then the molarity, along with sometimes the formality also. Okay, let's move on to the fifth concentration term. After normality, first molarity one category, then we are having the normality and formality in the second set. Next we will move on to the fifth category. The fifth one we are having, fifth, sixth, okay. Fifth we will have mass percentage, then sixth we will have the volume percentage, and the seventh we are having the third set, seventh set we are calling that as mass volume percentage. Mass volume percentage. Mass percentage separately, volume percentage separately, and then the mass volume percentage. So what is this here? It is the mass of the solute, substance of the solute, present in exactly 100 grams by mass of the respective solution. It is the mass of the given substance or a solute that has been present in exactly how much? 100 grams of the mass of the solution. Means we are taking the what? 100 grams of the solution. In that 100 grams, what is the mass of the solute that has been present? It is called as mass percentage. Okay. So here, with respect to volume percentage, it is the volume of the solute. Volume of the which one? Solute. Present in exactly 100 cm cube. Present in exactly 100 cm cube by volume of the solution. Means we are taking the what? 100 cm cube. Here we have taken the 100 grams of the solution. There we are taking the 100 cm cube of the solution. In 100 cm cube of the solution, what is the volume of that particular substance called as solute? And that is called as what percentage? Volume percentage. And lastly, we will have the third one in the form of mass volume percentage. It is the mass of the solute or the substance present in exactly, present in what? Exactly 100 grams by mass of the respective solution. Present in exactly how much? 100 grams by mass of the, volume means it is mass of the substance present in exactly 100 cm cube by volume of the solution. Observe the difference here. This is mass, this is mass. Means both are in mass, that is what is called as mass percentage. This is volume, this is also volume. That is what is called as volume percentage. But here, solute is in mass and the solution is in volume. That is what is called as mass volume percentage. But in every case it is 100, 100, 100 means it is referring to the which one? Mass percentage. So mathematically, mass percentage is given by the formula. How to calculate mass of the percentage? Mass percentage here, W2 divided by W into 100. What's that? Mass percentage is what? What is W2? Mass of the solute. Mass of the solute divided by what is W? It is mass. No subscript means it is the mass of the which one? Solution. Present in how much grams? 100 grams by mass of the respective solution is called as what percentage? Mass percentage. Similarly, we will have the volume percentage. Volume percentage is given by V2 divided by V into 100. Means both are expressed in volume here. What is V2 here? Volume of the solute. Volume of the which one? Solute. What is V here? Volume of the solution. Because no subscript means it is the volume of the solution. Present in how much? 100 cm cube of particular volume of the solution, then that particular is called as what percentage? Volume percentage. Next we will have this one. That is mass volume percentage. It is W2 divided by V into 100. What is W2 here? It is the mass of the solute. Mass of the solute divided by what is V? Volume of the solution. Present in how much? 100 parts by volume of that particular solution, then that particular is called as which one? The mass volume percentage. Means if both are expressed, solute and then the solution are expressed in mass with respect to 100, and then it is called mass percentage. If both the solute and then the solutions are expressed with respect to volume in terms of 100, then it is called as volume percentage. If solute is expressed in mass and the volume of the solution is R, the volume is expressed in volume into 100 parts by volume of that particular solution, then it is called as which one? Mass volume percentage. Okay, so that makes a difference between the mass percentage, volume percentage, and then the mass volume percent. Both are is in mass, then it is mass percentage. Both are in volume, then it is called as volume percentage. If solute is in mass and the solution is in volume, then it is called as mass volume percentage. In every case, just we have to multiply that by which one? The 100, because it refers to the percentage. Okay, so this is about the fifth, the sixth, and then the seventh concentration term, which are collectively called as mass percentage, volume percentage, and finally the which one? Mass volume percentage. Okay, let's have the next one. Another two we left with. Now we are left with the eighth. Parts per million. It is represented as ppm. Parts per million. What's that here? It is the number of parts by mass or volume of a solute present in exactly 1,000,000th parts by either mass or volume of the given solution, then it is called as which one? The parts per million. Instead of 100 parts, if I mention how much 1,000,000th parts means, it is called as parts per million. I don't know whether that solute may be expressed in terms of mass or it may be the volume. Anyone can be chosen here. Similarly, with respect to solution also, either it may be the mass or it may be the volume we can choose. Therefore, we can't have the exactness here. Or generally, what usually ppm or parts per million is represented usually in the form of, it is W2 divided by V into 10 to the power of 6. This is the most familiar term with respect to the very low concentration of the solution. That is the in every 1,000,000th parts by mass of the given solution. What is the number of parts by mass or volume of the given solute? Then it refers to the which one? Parts per million. W2 refers to what? Mass of the solute. What is V? It is the volume of the solution. We don't know whether it is expressed in cm cube or it may be the dm cube, whatever it may be. Into 10 to the power of 6. 10 to the power of 6 is called as what? 1 million, and that term is called as which one? The parts per million. Usually this term is expressed for having the very lower concentration, means the amount of the solute is very small as compared to that of the large amount or volume or mass of the given solution. Then you have to express that by which one? The parts per million. Okay. So lastly we will have the what fraction? Mole fraction. This is having a symbol of what? X. What's mole fraction here? It is the number of moles of either a solvent or a solute. I don't know exactly whether it is a solute or it may be the solvent. It is the number of moles of a solvent or a solute present in the total number of moles of a solution. Means it is indirectly the mixture of which and which? Solute and then the solvent. Because we know that the homogeneous mixture of which and which? Solute and then solvent is called as which one? Solution. Means if I take the number of moles of a solute, if I take the number of moles of a solvent and mix up these two, we are getting the total number of moles of the solute and then the solvent, or indirectly it is the total number of moles of which one? The solution. And that particular ratio is called as what fraction? Mole fraction. Mathematically, x1 is equal to n1 divided by n1 plus n2, or x1 is also equal to n1 divided by n. Similarly, x2 is equal to n2 divided by n1 plus n2, or x2 can also be equal to n2 divided by n. So what is x1 here? Mole fraction of 1 means solvent. Mole fraction of a solvent is equal to what is n1? Number of moles of solvent. n1 is number of moles of solvent divided by what is n1 plus n2? Total number of moles of the solvent and then the solute. What is the number of moles of the total solvent and then the solute means nothing but n. What is n refers to? Number of moles of no subscript, means it is a solution. Means number of moles of a which one? Solute divided by total number of moles of the solution is called as a mole fraction of solvent. Similarly, what is x2? Mole fraction of what? Solute. Is equal to what is n2? Number of moles of solute divided by what is n? Total number of moles of both the solute and then the solvent, or indirectly it is the total moles of which one? The solution. For a binary solution, preferably, we are having a binary solution, means containing only the solute and then the solvent. x1 plus x2 is always equal to 1. For a which one? Binary solution. Binary solution means we are having only two components, one is a solute and one is what? Solvent. Then the mole fraction of both the solute and then the solvent is called as, is always equal to how much? 1. Means x1 is usually less than 1 and x2 is always less than 1. Why? Because number of moles divided by total means the value is always less than 1. But if I add the sum of the mole fractions of both the solute and then the solvent, that value is always equal to how much? It is equal to 1. So this is the last concept that is in the form of which one? The mole fraction. So totally we are having how much? The 9 different concentration terms we are using. Molarity, molality, normality, formality. This is under one category. Then mass percentage, volume percentage, mass volume percentage. This is the second category we are. And lastly, we are having the parts per million and then the what fraction? Mole fraction. So these are the 9 different terms to express the strength of a solution, and that strength of a solution is also called as which one? The concentration of a solution. Okay. So after this, now we are moving to the concept called as which solutions only we have to concentrate. We have to concentrate strictly on the which solution? liquid solutions. Means liquid solutions means it is a homogeneous mixture of which either a solid or a liquid or a gas in the liquid solvent is called as what solutions? Liquid solutions. Means solvent is fixed. What is that? Liquid. What is the solute? Either it may be a solid or a liquid or it may be the gas. And that particular combination is called as what solution? Liquid solution. So here, as if we know that this is having a 3 times. What is that? SL solution, LL solution, and then the GL solution. Means solid liquid solutions, liquid solutions, and finally the gas liquid solutions. Okay. So to have the concept of the liquid solutions, we have to be very familiar with the terms called as what is solubility, what is dissolution. You have to be very familiar with these 2 terms, that is called as solubility and then the dissolution. They are found to be the different actually. Okay. So that we will discuss in the next session of this particular chapter, that is called as solutions. Okay. So thank you very much.